Hello, my mathematicians. This is Miss Foster with Math in Focus, Grade 4, Chapter 6, Lesson 8, Real Word Problems with Fractions. Now, if we're solving word problems with Math in Focus or Miss Foster, you know we're drawing all the bar models. Let's get going. So the first one is adding more than one fraction. Three friends shared a grapefruit. Elena ate a third of the grapefruit. Lee ate a ninth of the grapefruit, and Sarah ate 3/9 of the grapefruit. What fraction of the grapefruit did they eat altogether? Well, let's see. I would have labeled this. I would have called it a grapefruit. And here's Elena. I'm just going to draw this little bracket here and say that this is Elena's part. Oh, Lee ate just one. This is Lee's part. And then here we have Sarah's part right here. I like to label that stuff. And then I notice that I'm trying to add 1/3 plus 1/9 plus 3/9. And look, they've found the problem. The problem is we can't add parts that are not the same size. So we had to take this 1/3, and I'm going to show this to you. If I were to divide it up into 3 parts, I'd have 1 part, 2 part, 3 parts. And if I take one of those thirds and divide it into 3 parts each, I will have ninths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so by finding that common denominator, we can figure out the answer. So I'm going to use equivalent fractions to multiply it by 3/3. 1 times 3 is 3. 3 times 3 is 9. Then I've got 3/9 plus 1/9 plus 3/9. And I'm going to wind up with 7/9. Sweet. Now let's try it here where we don't have it all drawn for you. Sean, Roger, and Damon each drank different amounts of milk one day. Sean drank 5/6 quart of milk. Roger drank 7/12 quart of milk, and Damon drank 11/12 quart of milk. How much did they drink altogether? Well, just to save time, I already drew my bar model, but I want to gently show to you that I started off by drawing each of them a bar. I'm giving each one a bar this time. Sean's, Roger's, and Damon's, you are allowed to abbreviate. Use all the abbreviations you want. And I decided that each box would stand for a quart of milk. So first I took the boxes and I divided them into 6, and I saw that Sean ate 5/6, drank. And then I took Roger's and Damon's. They both have 12ths going on there. So I showed Roger's 7/12 and Damon's 11/12. But then I knew I was going to have to get these all to be the same size. So here is what we could write. We're doing 5/6 plus 7/12 plus 11/12. Now I can divide 12 by 2 to get down to 6ths, but I can't divide 7 by 2, and I can't divide 11 by 2. So instead I'm going to use my multiplication strategy here and multiply 5/6 by 2/2. And here's what that would literally look like. I am doing 5 times 2, which would be 10, and 6 times 2 would be 12, and we multiply them both by the same factor because look, I cut every one of those pieces into halves. Each one of these 6 has been divided into 2 halves, this half and that half. And now you can see the pieces are all the same size. We just need to bring our math along with it. So here I've got 10/12 plus 7/12 plus 11/12. When I add it all up, let's see, 10 plus 11 is 21, and 21 plus 7 will be 28/12. And I will wind up with this beautiful improper fraction. But is this its simplest form? Aha! We're going to express all our answers in their simplest form. So let me see. How many groups of 12 can I get out of the number 28? Well, I know I can get at least one. 12 plus 12 is 24, so I think I can get 2. If I had 28 and I took away 24, then that would leave me with 4 of them, right? So I'm going to propose that we have 2 and 4/12 of quarts of milk. But am I at my simplest form yet? I don't believe so, because 4 and 12 share a factor, and the factor they share is 4. So if I take 4/12 and I divide it by a variation of 1, this time being 4/4, well, 4 divided by 4 is 1, and 12 divided by 4 is 3. And so the answer in the simplest form would be 12 and a third. Cheryl and Dennis shared an apple. Cheryl ate 2/5 of the apple. Dennis ate 3/10 of the apple. What fraction of the apple was left? Well, I think 2/5 right here, this would be Cheryl's, and this would be Dennis's. And we notice that they are different size pieces. So really the fifths are this big. That's how many fifths we have. But you can see that with an odd number of tenths, there's no way we're going to be able to use fifths. So we're going to use our equivalent fraction skills to multiply 2/5 by 2/2, and 2 times 2 is 4, 5 times 2 is 10. Now we can do 4/10 plus 3/10, and we will find that the answer is 7/10. Is that in its simplest form? Well, 7 is a prime number, so its only factors are 7 and 1, and 7 is not a factor of 10. So we found it. Terry had to travel 12 miles from town A to town B. He traveled 5/8 of a mile by bus. He traveled another round 1/4 of a mile by car just before the car broke down. How far was he from town B when the car broke down? So in this one, first we regroup. 12 becomes 11, and let's see, we've got to make a decision here. What size pieces are we going to use? Well, 8 divided by 2 is 4. But you can't divide 5 by 2. 2 is not one of its factors, and we don't want fractions of fractions. That would be silly. So I think we should use our equivalent fraction skills to make 1/4 into 8ths. So I'm going to change 12, that whole number, into an improper fraction of 11 and 8/8. So this is 11 and 8/8 there. And we're taking away 5/8, and we're also taking away, let's see, we're going to multiply this by 2/2. 1 times 2 is 2. 4 times 2 is 8. And both of these are negative. This is a negative 2/8, and this is a negative 5/8. That means subtract 5/8 and then subtract 2/8. So 8 minus 5 is 3, and 3 minus 2 is 1, which brings me to my answer of 11 and 1/8 miles. Method 2 would be to take these two and put them together. And we're going to use the same denominator. So this comes together to be 7/8, and then of course we would have 12 minus 7/8, and we would then change that to 11 and 8/8 minus 7/8, and I'm not going to write this anymore. You're going to get back to here. Then here's the sentence. He was 11 and 1/8 miles from town B when the car broke down. Judy bought a few pieces of fruit. 2/5 of them were pears. She bought 12 pears. How many pieces of fruit did Judy buy altogether? Do you see how we're using that fraction of thing, but now they're making you go backwards? If we drew it all out, if this was all of Judy's fruit, I would probably label it myself. We don't know how much she has in all, there's the question mark, but we know that she divided it into fifths. 1, 2, 3, 4, 5. 5/5. 2 of them are pears. 12 divided by 2, this is where we're finding the unit fraction, the 1. What is 1/5 here? And I think you've already figured out that would be 6. So 6 is 1/5. How many pieces of fruit did she buy altogether? Well, wouldn't that be 6 times 5? 6, 1, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. And 6 times 5 is 30. And so there we go. Vincent spent 4/7 of his money on a pair of shoes. The shoes cost $48. How much money did he have at first? Now, I, of course, would like to label this as Vincent's money. And you can see that on this bar model, they've divided up into 1, 2, 3, 4, 5, 6, 7 pieces. And we know that the cost of the shoes was $48, and they were equal to 4 of the 8ths. So it seems to me that if I took 48 and divided it by 4, I would know the 1, or the unit fraction. If I know what 1/7 is, I can answer the rest of the questions about it. So let's do some division here. Well, in the tens place, 4 times 1 equals 4, so we'll give 10 to every single one of those parts. And I can actually show my division here. I'm going to give 1 10 here, and 1 10 here, and 1 10 here, and 1 10 here. And that means I'm left with 8 single ones. And 4 times 2 equals 8. And you know what? I don't even need to do any more. You know that we're done because 4 times 2 is 8. I'm just going to stop working on that part and get those 2 single ones over here so you can see my division. Now that means that 1/7 is 12. So if we want 7/7, we would take 12 and we would multiply it by 7. Hello, multiplication and division skills that we've been working on all year. 7 times 2 is 14. I'll leave those 4 single ones there and bring my 10 back up to the tens place. 7 times 1 is 7, plus this extra 10 from the single ones place makes 8 tens. And so I can see that the amount he had at the end was 84. A pitcher contains a liquid mixture of water and lemon juice. The water makes up 2/5 of the weight of the liquid mixture. There are 25 ounces of water in the pitcher. How much lemon juice is in the pitcher? My friends, here's the mistake I made the last 2 times I recorded this. I didn't label this, and I should have. These 2 boxes are the water, and these 2 boxes represent the lemon juice. So I have 25 ounces, and to figure out the unit fraction, I'm going to need to divide 25 by 2. And that may feel a little squidgy to you because, 25 is not an even number. We're going to have a remainder here. Let's see how we can handle this. Well, first of all, in the tens place, 2 times 1 is 2. So each one gets 10. And if I give 10 to each one of those fifths, then I'm going to take away 2 tens. So I'll do that quickly. That leaves me with 5. 2 times 2 equals 4. And will leave me with a remainder of 1. So that means each one of these has 2 single ones. Now, I hope you can see that we've got one left, but we've been working with fractions, so we can handle this. We could write this as 12 and 1 divided by 2, or 1/2. Now, it's hard for me to squeeze all this in here on the screen, so I'm just going to write these down here and hope that you can forgive me. Every one of these boxes is 12 and 1/2. So to find out the lemon juice, I would need to multiply 12 and 1/2 by 3. For me, I'm going to break that down into whole numbers and then fractions. So 12 times 3 equals 36. If you needed to do that with long multiplication, that's fine. I'm going a little faster for the video. But now I've got to do 1/2 times 3. And to think about this, I'm going to say, well, if I have this 1/2 and this 1/2, if I put them together, they'll make 1 and 1/2 right here. So I'm going to take 36 and add 1 and 1/2 to the 36. And 36 plus 1 is 37, and 37 plus 1/2 is 37 and 1/2. And if I took this number and wrote it into this little tiny box, I would have my whole sentence. The weight of lemon juice in the jug is 37 and 1/2 ounces. So now we're involving some subtraction here from whole numbers, which with subtraction we have more than one way of looking at it. So let's take a look first of all at what this young friend is telling us about Sally, and then we'll talk about Dante's problems together. Sally had 18 stamps. She sold 1/3 of them. How many stamps does she have? Well, we could do it as the whole thing minus 1/3 is the same as 3/3 minus 1/3. 3/3 is still 1. And 3/3 minus 1/3 is 2/3. She has 2/3 of her stamps left. These are the sold ones, and these are the left ones. Now, another thing that we could do is we could say, well, there are 3 units in 18, and one of them will be 6, and so 2 times 6 is 12. Golly, I think this is the one that I was just doing. Up here they did 2/3 times 18. 2 times 18 is 36. And 3 times 1 is 3. And 36 divided by 3 is 12. So that's how she had 6 stamps left. But I sort of like it right here as getting those 6's in there. Let's try this one together. Dante had $50. He uses 3/5 of it to buy a jacket. How much money does he have left? Well, these 3/5, this is the jacket down here. This is his money. And let's see, this was $50 total. So now I've got to know what 1/5 is. 5 units, 5 of those boxes there is $50. And 50 divided by 10 equals, oh gosh, you guys, I'm sorry, it's actually divided by 5 because we're putting it into these 5 boxes. And you already know that it's 10. And now if I want to know what 2 units are, I would do 10 times 2. And that would give me 20. So he has $20 left. Oh my goodness, you guys, there's so many different ways that we can work on fractions with word problems. But for me, it's the bar models that are saving me every time. Draw, draw, draw. Guys, I love playing math with you. Bye-bye for now.